Welcome back to Trig Notes 2.2 or Pre-Calc Notes 5.2. We're going to continue working with verifying identities. So if I asked you to verify that these two fractions added together would equal 0, the first thing that I need you to do is add these two fractions together. And then to be able to add fractions together, we have to have a common denominator. So the easiest way to find the common denominator when they are binomials like this is to make the common denominator be both of these multiplied by each other. So I'm going to make two new fractions. With sine x plus sine y times cosine x plus cosine y as the denominators. And then I want to add these together to show that they equal 0. Okay, so if this has the denominator right now of sine x plus sine y, it's missing the cosine part. So what I have to do is multiply all of this up here by cosine x plus cosine of y. Get that a little bit neater. And then this one over here, it has the cosine x plus cosine y. It's missing the sine x plus sine y. So essentially what that's going to be is that's going to be a FOIL problem. I'm going to have to FOIL these and FOIL these. So if we FOIL these together, I get cosine times cosine is cosine squared x. Then I have a negative cosine x cosine y and positive cosine x cosine y. So those will end up canceling out from each other. And then when I multiply the last two, cosine y times negative cosine y, I get negative cosine squared y. I'm going to see a similar pattern when I multiply these together. Multiplying the first together, I'm going to get sine squared x. Multiplying the outers together, I get sine x sine y. Here I get negative sine x sine y, so they'll cancel out. And then finally multiplying the last together, I get negative sine squared y. So now what I can do is I can write this, I can combine this together as writing it as one denominator. So my denominator is sine x plus sine y cosine x plus cosine y. Now when I combine these together, the way I'm going to choose to do it is take my x terms, which is this and this, and put them right next to each other. So cosine squared x plus then this sine squared x. And then I'll take these, the negative cosine squared y and the negative sine squared y, and I'll put those together. So minus cosine squared y, and then plus a negative would be minus sine squared y. Alright, I deliberately wrote it like that so that I could look at this and I could work at consolidating that. Hopefully by now you're noticing that that is the Pythagorean identity, that is the same as 1. So look at your Pythagorean identity sheet, your formula sheet. You should see that this is exactly the same as 1. Now over here, this is close to, similar to cosine squared plus sine squared, but I've got minuses with it. So what I want to do here is factor out the greatest common factor. So I'm going to factor out the greatest common factor of a 1, which would make it be cosine y plus cosine squared y plus sine squared y, all over my denominator. You notice I haven't really done a whole lot with my denominator once I've found what it was. My end goal is if I can get my numerator, the numerator to be equal to 0, then I don't really care what's down here because 0 divided by anything is going to get me 0. So my goal is to try to get this to be equal to 0. How do I do that? Well, I keep making more substitutions. This now is the Pythagorean identity, that is 1. So now what I have, if I come over here, I have 1 minus 1 times, this is a 1, over sine x plus sine y times cosine x plus cosine y. And now I was able to get this to be equal to 0 because it's going to be 1 minus 1. And 1 minus 1 is 0. So I get 0 over this whole denominator, which I'm not going to take the time to write again. 0 over that is equal to 0. So therefore I show that 0 is equal to 0. And I could simplify that. So what is my thought process as I'm doing a problem like this? It's complicated with this problem because of the fact that you're trying to add two fractions together that don't have really nice denominators to work with. So when you see denominators like this, just multiply them together to get your common denominator. And then my next thought process was I see a lot of sine squareds and cosine squareds, so I should be thinking the Pythagorean identity with that. And remember that the cosine squared plus the sine squared, that's the Pythagorean identity that's equal to 1. So when you have the minuses like you do here, you want to factor out the greatest common factor, which in this case was a -1.